Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in microprocessor, microcontroller and interfacing techniques subject. We're going to see 8251 USART. In previous videos we have seen programmable peripheral interface and programmable interval timer, and today we're going to see programmable communication interface, which is 8251. So in this video we're going to see the working of 8251, the functional block diagram of 8251. Before seeing the working of 8251, we have to know what is 8251, what is the importance of 8251. We call it as USART, which is Universal Synchronous Asynchronous Receiver Transmitter. This particular IC, 8251 IC, is called as Programmable Communication Interface IC, where the main objective of this particular IC, the main need of this particular IC is used for serial communication, used for serial data transfer. That is, this 8251 is capable of converting a serial data into a parallel data, and it converts parallel data to serial data, and it helps in serial communication, which means this 8251 is interfaced with microprocessor, and we know that microprocessor is capable of handling parallel data. So whatever data that is received from microprocessor, it will be in parallel form. So this 8251 will convert this parallel data into serial form and it will transmit it. And similarly, whenever it receives data, it will receive the data in serial form and it will convert it into parallel form and give it to the microprocessor. This is the importance of 8251, the main need of 8251, where it supports serial communication. So in this video, we will see the functional block diagram and working of 8251, right? So as I said, this 8251 is called as Universal Synchronous Asynchronous Receiver Transmitter, which will act as a mediator between a microprocessor and the peripheral device. So whatever data that it is received from peripheral device, it will be a serial data. So it will convert that serial data into parallel form and it will give that parallel data to the microprocessor. And similarly, whenever microprocessor sends any particular data, it will be in parallel form. So it will convert that parallel form into serial and it will transmit that particular data. Right? You can see here it takes data serially from peripheral and converts into parallel data. After converting the data into parallel form, it transmitted to the CPU. Similarly, it receives parallel data from microprocessor and converts it into a serial form and it transmits that serial data to the outside device. Right? This is the main purpose of USART 8251. Right? So now we'll see the functional block diagram of 8251. So it is used for serial data transfer. So we have two important things. One is transmit buffer and receive buffer. And we have data bus buffer as well. Right? So this transmit buffer, it's used to transmit data, and this receive buffer is used to receive the data from the peripheral device. Right? So now when you say transmit buffer, we can call it as like parallel to serial converter. This transmit buffer is the one which converts the parallel data which is received from the microprocessor into serial form and transmitted in the serial form. Similarly, this receive buffer, it will act as a serial to parallel converter, which means it will receive data serially from the peripheral device and will convert that into parallel form and give to the microprocessor. Right? And apart from this, the very important thing is data bus buffer, where this data bus buffer is interfaced with the microprocessor system bus. Right? So any particular data that has been transmitted between microprocessor and 8251, it will be happen only in this data bus buffer. And we have a read-write control logic, where these are the control signals which is important for this 8251. Right? And this CS is nothing but chip select. Whenever the CS is low, you know that whenever we have CS bar, that this signal will be active when it is 0 and it will be inactive when it is 1, right? So if it is 0, it will select the 8251 chip select, and if it is 1, it does not select the 8251, right? And C by D bar, this is another important signal where C by D bar, now you can understand, if this pin is 1, it represents the control word register, and if it is 0, it represents the data bus buffer, right? So if it is 1, it represents the control register, and if it is 0, it represents the data bus buffer. And similarly, we have a clock signal and we have a reset signal. A reset signal is another important signal where if there is an active input in this particular signal, if it is active input, then it will force this 8251 to ideal mode. It will reset the 8251 and it will put it to the ideal mode, right? And we have two important signals, with this a read and as well as a write, and both will be active when it is active low. That is, whenever it has a 0, right, it will be active, and if it is 1, it is not active, right? And this read signal is interfaced with the memory read or IO read of microprocessor. It will be interfaced with the memory read signal or IO read signal. It depends upon how it is interfaced. And similarly, this write signal, write pin, it is interfaced with the write pin of microprocessor. It can be memory write or IO write, right? And apart from that, the very important thing is it has modem control, right? This modem control has several control signals, which is DSR, which is nothing but data set ready. Whenever data set is ready, it will be indicated by this input pin. And similarly, data terminal ready, that is, whenever there is data to be sent, right, data terminal is ready, this pin will be active. And we have two control signal, that is clear to send. It is a clearance for the 8251, and that is an input signal, right? Clearance, clear to send, right? That is clear to transfer any particular data, right? So that is CTS. And RT is something but request to send, that is an output signal. Whenever it needs to data, it requests for a data or a request for a communication, this particular pin will be enabled, RTS, right? And apart from it, we have transmit control and receive control, where transmit control is connected with the transmit buffer, right? And whenever we need to transmit data, that is 8251 transmit data from microprocessor, right, that will be transmitted in this transmitter pin, TXT. And similarly, whenever the 8251 receives data, that is microprocessor want to receive data from peripheral, that will be received in this particular RXT pin, receiver pin, right? And this transmitter control will have three important pins, which is transmit ready, right? Transmit ready in the sense it indicates that the transmit buffer is ready to transmit the data, right? And similarly, whenever the transmission is over, that is, this particular transmit buffer is empty, it will be indicated by this particular pin, TX empty. TX empty in the sense it has transmitted all the data and it is ready to receive, ready to transmit the other data, so that the microprocessor can send more data to this transmit buffer, right? So TX empty represents that transmit buffer is empty, and whenever it is ready to transmit data, this pin will be active. And similarly, whenever the receive buffer is ready to receive data, that will be enabled by this particular pin. And TXC and RXC is nothing but the clock signal, right? And we have the final pin, which is this pin can be used as input and output terminal, and it supports both synchronous and asynchronous communication, right? So the main important advantage here is the USART is used for serial communication, and it supports both synchronous mode and asynchronous mode, right? So whatever I just explained, that is what given here. You can see data bus buffer, that is connected to the system bus, right? And read control logic, it will be connected to the microprocessor, and it will be selected whenever there is active low signal. And similarly, we have modem control, where we have DSR, DTR, CTS and RTS signal. I have explained all those things, right? And this is very important working of 8251. You got to understand the original operation of 8251. right? So how these control signals will work, right? So we know that C is nothing but chip select, and whenever it is 0, it selects the 8251, and whenever it is 1, it does not select the 8251, right? So whenever it is 1, it is inactive. 8251 is inactive. So whenever it is 0, it is selected. That is 8251 chips is selected. And I already said about a read signal and write signal and C by D signal. Once again, I'll tell you, whenever this pin C by D is 1, which means it enables the control word register, and whenever it is 0, it enables this data bus buffer, and whenever this read pin is 0, it is active, and whenever it is 1, it is inactive. And similarly, whenever this pin is 0, it is active, and whenever it is 1, it is inactive, right? Now if it is 1, this is inactive, it does not select 8251, right? And now if CS is 0, it selects the 8251, and if C by D bar, this C by D signal is 0, then it selects the data bus buffer, and if RD is equal to 0, then the read signal is active, and when WR is equal to 1, it makes the WR as inactive. So which means it represents the data bus buffer and the read signal, which means the CPU can accept the data from the data bus buffer. That is, it accepts the data from 8251, right? And now again, if C is equal to 0, it select the chip select 8251, and C by D is equal to 0, which once again represents the data bus buffer, right? And here the read signal is equal to 1, so it is inactive, and write signal is 0, which means it enables the write operation. So here the data bus buffer and write operation is enabled, which means the CPU writes the data on the data bus buffer, performs the write operation on the data bus buffer, which means it outputs the data to 8251, right? And similarly, once again, CS0 represents the chip select 8251, and C by D is equal to 1, which represents the control word register operation, and read signal is active and write signal is inactive. So in this case, the read operation is enabled, which means the CPU will read the control register of 8251, right? So here 1 represents the control word register and 0 represents the read operation. So the CPU will read the control word register, right? And again 0 represents the chip select, and C by D 1 represents the control word register, and RD is equal to 1 represents read signal is inactive, and write signal is 0 represents that write signal is active, which means CPU will perform write operation, that is microprocessor will write on control word register, right? The write operation will perform on the control word register. So you got to understand this operation very clearly here, right? So in this condition, the CPU accepts the data from 8251, and in this condition it writes the data, that is output transmits the data to 8251, right? And these two represents the data bus operation, and these two represents the control word register operation, where here read operation is performed. It reads, the microprocessor reads the 8251, and here it writes the it performs write operation in control word register. This is the overall operation of 8251, right? And I want to explain what is transmit buffer. It is used for parallel to serial converter, whereas transmit buffer, it converts serial to parallel converter, right? And whenever it has data to transmit, it will be transmitted in this particular pin, TXT pin, right? And TX ready, it represents that whenever the transmitter is ready, it will be indicated in this particular pin. And whenever the transmit buffer is empty, that is it transmitted all the characters, that will be represented by this particular TX empty pin, right? And TXT pin is the clock signal for transmitter, and similarly receive buffer, as I said, it will act as a serial to parallel converter, right? And similarly the RXT signal is the input signal which receives the data, and RX ready indicates that whenever the receiver is ready to receive the data, right? And again, RxC here can be used as a clock signal, and this is very important pin where it can be used as an input and output terminal, whereas in input terminal it works as in synchronous mode, and output mode it will work as an asynchronous mode, right? So this is the overall working of USART 8251. Coming to the advantages, it is very versatile, that is, it works in both synchronous and asynchronous mode, and it has error detection like parity checking to ensure accuracy of transmit data, and it has flow control which regulates data transmission and reception, and compatibility where it is compatible with wide range of microprocessor, right, basic microprocessors, and it is very easy to use. These are the advantages of 8251. Coming to disadvantages, the speed is very limited, even though it transfers it is used for serial data communication. The data transfer rate is only 115.2 kbps, right? And it is insufficient for some application, and the buffer size is very limited. And similarly, the programming USART is bit difficult, right? And cost wise, USART is really affordable, but when we try to use multiple number of USART, then it will increase the cost as well. And coming to functionality, it has limited functionality because it is used for only serial communication and does not have the additional features like direct memory access and advanced error corrections, right? So this is about 8251 USART, that is peripheral communication interface. So today what we have seen is, we have seen the working of USART 8251 peripheral communication interface. We have seen the block diagram and the working of 8251. I believe this video will be very useful for you. Thank you, my dear students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.